I am on page 191 and we're looking at problem 3. And rather than copy this, I did go ahead and just take a screenshot so that we don't have to sit here for an hour and write this down. Which situation could be represented by the function f of x equals 8x? Well, the first choice is that Lindsay bought 8 pieces of candy for $1. So this would be 8 pieces equals $1, or 8x equals $1. Pat earns $8 per hour, so the income is $8 per hour, or 8x. Ken worked for 8 hours, so this would just be time equals 8 hours, or time equals 8. I guess I should leave off the word. And Julian sold 8 more raffle tickets than his cousin sold. So Julian equals 8 more than his cousin. So the one that fits this pattern is B, where f of x, or let's say I of x, income of x hours, equals 8x. You could just as easily substitute f of x. The letters don't matter. It's the pattern that we're looking for. So I would go with B on this one. $8 times x hours. Okay, number 4. Let me just crop this one to get just the problem we want. And we'll take a look at number 4. Lou ran at a speed of 8 miles per hour. Write a function to represent the number of miles that Lou would run in x hours if he maintained this speed. So the function would be where x is going to be hours, it would be 8 miles every hour. So there's the function. That would be this answer. If Lou could run at this speed for 2 hours, what distance would he run? So let's build a table of values just to see what we come up with. We can also use this to answer the rest of the questions, and it's also just good practice. Remember some vocabulary terms. We started out with x's and y's, and then we learned x and f of x, and you've also learned domain and range. And let's throw in one more because I am going to graph this one. Independent and dependent. So we know that he can run 8 miles in 1 hour. And actually I've got it backwards, excuse me. After all that, and I have it backwards. X is going to be the hours, and the miles depend on the number of hours he runs. So 1 hour, he runs 8 miles. B is asking if he ran 2 hours, how many miles would he run? So we want to say when when x is 2, he would run 16 miles. I'm going to go ahead and add a couple more just for practice because I do want to graph this one. So I have f of 3 is going to be 8 times 3. So if he runs for 3 hours, he will cover 24 miles. Now I'm going to leave that last space blank for just a second because I suspect question D, question D, we're going to need to break this down. All right, so if Lou could run at this speed for 2 hours, what distance would he run? 2 hours gives me a distance of 16 miles. Is the function 1-to-1? I'm going to wait on that one. I can answer it right here, and you probably can too, but I am going to wait on that one. Just a second. At this speed, how many minutes will it take Lou to run 1 mile? So this time I'm going to use this last row, and we want to know the number of minutes. So we're actually looking for x, and we only want him to run 1 in the mile column. So this time we're going to substitute 1 for the output and 8x. So then we will solve for x. Now, this is 1/8 of an hour. To convert that to minutes, we would say 1/8 of 60. And you will multiply there, 1/8 times 60. Use your fraction key. And you will get 7.5 minutes. That is 1/8 of an hour. Because the question asks us how many minutes it will take. So we have to be very careful and make sure we answer in terms of minutes. All right. Is the function linear or quadratic? And explain. Well, we can explain this one by looking at the degree of the function. It is linear because it is a first degree. I lost the word is. It is a first degree function. The x is not to an exponent other than 1. And that is a linear function. Okay, back to C. The reason I wanted to wait on C is to have as many points as possible to put in here. So remember, if we want to know if it's a function, we have to look at the x values. They cannot be duplicated, and they're not. I also know that for every hour he runs, the distance will change, and that tells me that this is a function. The question is 1-to-1. Is it 1-to-1? And remember, to test that, you have to look at the y's. You cannot have any duplicates in the y's. So yes, it is 1-to-1. There are no duplicates in the outputs. And I said I was going to graph this one, but I think I'm going to wait. We'll get plenty of practice graphing. And this has a lot of information already. Okay, here is number 5. Let me paste this down here and crop out what I don't need. We don't need any of the problems except number 5. And I need to read this one to know if I'm going to have enough room. I believe I will. Yes, we do. The function h of t equals negative 16t squared plus 400 gives the height h in feet of a ball t seconds after it has been dropped from a height of 400 feet. What is the value of this function when t equals 5? What is the meaning of this value in the context of the problem? So let's take a look. H of t equals negative 16t squared plus 400. So to answer the first question, what is the value of this function when t is 5? We just need to substitute 5 for t. And then we need to evaluate that function. So 25 times negative 16 plus 400. So 16 negative times 25 positive is negative 400. Plus 400. So h of t, h of 5 is 0. So we have just answered the question. After 5 seconds, the height would be 0. I am going to graph this one. This is a good one to graph. And then we'll come back and answer that second question. So I'm going to put in a table of values. Something like this. And I'm going to use t and then h of t. And I need one more. No, I've got enough. Sorry. Okay. When t is 5, h is 0. Now, I know that this is an x-intercept, which is important. We'll see when we graph it why it's important. Okay, to build this table of values, I'm going to pick some others. I'm going to look at the y-intercept. I'm going to look at 1, 2, 3, and I'll tell you what, let's go ahead and put in 4. So I am going to add another row. You can add all you want to, or take away all you want to. So 4 and 5. We already know 5 is 0. That's the x-intercept. And we know 0. At 0 time elapsed, that's where we began. So when no time has elapsed, the ball is at 400 feet. So this is the y-intercept, and that will be important when we graph. So let's look at h of 1. So the height at 1 second is negative 16 times 1 squared plus 400. So that will be negative 16 times 1 plus 400. So after 1 second, the ball is at 384. Yes. So that would be this value. Then the height at 2 seconds will be negative 16 times 2 squared, that's 4, plus 400. So negative 64 plus 400. So 336, I believe. I'm trying to practice doing these in my head. That looks about right. Then when h is 3, we have negative 16 times 3 squared, that's 9, plus 400. So we have negative 16 times 9, that's negative 144, plus 400. And that is going to equal 256. And then finally, let me do h of 4. So that will be negative 16 times 4 squared, that's positive 16, plus 400. So negative 16 times 16 is 256, plus 400 is going to be 144. And then at 3, it was 256. Okay, so I have a table of values. I'm going to graph this picture. And I need to move this around a little bit to make room for a graph. So let's move h of 1 right down here. All right, we can do this in the first quadrant because we have no negative values. So let's do whoops. Let's straighten that up a little bit. The dependent variable is height in feet, and that variable depends on the time in seconds. Now, let me figure out my scale. We need to go from 0 to 400. So let's count the spaces in between. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to do 400 divided by 14. And that means that each one of them, I'm going to do it at about 30. So we have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, 390, and then there's 400. I need to not use it right there because that's going to throw the scale or the slope off a little bit. And then we have from 0 to 5 seconds. Now, remember we talked about one of those proportional graphs that has to pass the 0, 0 test? This one does not pass the 0, 0 test. Because when x is 0, y is 400. This is the starting point. 0, 400. When x is 1, y is 384. So somewhere right about there. When x is 1, y is 384. When x is 2, y is 336. Somewhere in there. When x is 3, y is 256. So somewhere right in there. When x is 4, y is 144. And when x is 5, y is 0. This is where it touches the x-axis. So here's the path of that rock that was dropped from 400 feet. Let me try one more time. This is half of a parabola. I'm going to freehand it because I'll never get it like that. So it's coming down this way, something like that. Okay. And here, remember, is the function. H of t equals negative 16t squared plus 400. Negative 16. That's a negative slope. The rock is falling, so that is consistent. Now, here's the rest of the question that we have to answer. What is the meaning of this value in context of the problem? We're talking about this point. And here's what they're looking for. At 5 seconds, the rock has 0 altitude. It's at 0 feet, which is another way of saying that it hits the ground. Okay, so we went through all that to make the graph and to see that when it's at 0 on the y-axis, it's the starting point. It's hitting the ground. When it's 0 on the x-axis, it's the starting point. So we started at 0 on the x-axis, and we ended at 0 on the y-axis.